Saxon Algebra 1, Lesson 103. You guys, I want to make a really important distinction for you that takes most students a while to kind of get settled in their head. So you may already know this, but I want to make a really big distinction. If I'm adding just adding these two numbers and there's no equal sign in this anywhere, right? This is called an expression. No equal sign. And yeah, I want to add these together, but it's not an equation. It's an expression. There's no equal sign in here. And technically what we're doing is called simplifying. Even though you and I know that this is going to end up saying equals something, that's not the way we present it in algebra. We consider this an expression, and that's important because when we have fractions that are expressions, we're limited in how we can put them together. What we do, remember, is we have to find the LCM, least common multiple. In this case, it would be 4. And then to make them match, we have to multiply top and bottom by 1. Or let me write that in more detail, by a fraction equal to 1. And I'll show you what I mean. Words fail to convey. This one's fine. We'd multiply this one by 2 over 2, right? In order to get it to match. And then we'd have 2y over 4 plus 1 over 4. And then we'd put them together. Right? And that would be our final answer. That's an expression, and in that case, all we can do is make the denominators match, right? It's the best we can hope for, is just to make them match. However, what we're going to talk about in this lesson is rational equations. So let me show you how that looks different. Oh, that has an equal sign and more information over here. This is an equation, and it's very simple. It has an equal sign. That's how you can tell, right? So the difference between an expression and an equation is, does it have an equal sign or doesn't it? And this one, even though I added one here, it doesn't up here. We're not solving in that respect. We're simplifying. With an equation, we solve, okay? So John's instruction very often tips his hand to you whether you have an expression or an equation, because he'll say simplify or solve. Good to know. Now, in this problem, this type of problem, we still need to find the least common multiple. And this one got more complicated because now we have the 6, right? So the LCM can't be 4 anymore, but it can be 12. Okay, good. Now, in these problems, we don't multiply top and bottom by a fraction equal to 1. We multiply every term by the LCM. Okay, so in this case, I'm going to multiply by 12, 12, and 12. Now, look what lovely thing that does. Because of the LCM's magical composition, every one of our denominators is going to cancel against that, right? 2 goes into 12 6 times. So I'm going to write a 6 in front of that y because that now is the new coefficient based on these two, right? Multiplying by 12 allowed me to cancel my denominator, but it gives us a new number in the numerator. That's okay. I can live with that. 12 and 4, that reduces to 3. And remember, we're multiplying. So in this case, I could just write the 6 in front of it. This time I'll see I have to multiply 3 times 1. That's easy. 12 and 6, that cancels, and it's 2. And again, I can just write that in front. It'll work out fine. So now look what happens. Once we make these changes, I get 6y plus 3 equals 2y. Oh, that's different, isn't it? So in this, here we could only make the denominators match. That was the best we could hope for. Here, we can eliminate denominators completely. Okay, huge distinction. So now, and we still have to finish solving this, I'll do that in a minute, but what I want to say is, now when you get a problem, the first thing you do is look to see if there's an equal sign or not. All right? That gives you two different strategies. If you have no equal sign, but you have fractions, the best you can do is a top and bottom thing to make them match and then combine them. You'll never get it to go away in an expression, unless the problem's set up so that they cancel for some reason. But most of the time, you'll be left with the denominator. If it's an equation, I want to put a big star by this because this is the starting point. If it's an equation, we still have to find the LCM, but we use a completely different strategy. We don't multiply top and bottom because that would just make the denominators match. We blow them up all together. I get kind of violent about this. I'm not going to lie. I refer to that as blowing up our denominators. And I consider these little sticks of dynamite that we carefully place. And we can eliminate them all together and move on happily. Therefore, I always enjoy equations just a little bit more than expressions because they're so satisfyingly complete. All right, but we have to start focusing in on that distinction so that we know how to approach the problem. Let me just finish this problem. I'm going to subtract 6y. I'm going to let the minus signs be damned. 3 equals minus 4y, and then I divide by minus 4. And my final answer is y equals negative 3 over 4. I hate floating numbers, but I prefer floating minus signs. So even though the minus sign was associated with the 4 in the denominator, when we write our final answer, we bring it out and let it float. Okay? That's the right answer. Yay. So in this lesson, we're focusing on equations and learning how to make the denominators go away. But I want you to be very clear that sometimes we're stuck with the denominators. When there's no equal sign and it's an expression, we're stuck with them. And all we can do is adjust top and bottom. Here, we can multiply and make them go away. All right? This is one basic rule of algebra. This is the another. We got 2 out of 3 going right here. Okay, there are 6 examples in this lesson. John has gone crazy in examples for you. But that's okay. It's just more practice. Solve. You copy and I'll check. Looks good. And John tells us in the instructions, solve. Okay, that's a big hint to us that this is an equation. And look, there's the equal sign. So we know it's an equation. Hallelujah. That means we get to blow up the denominators and eliminate them completely. Does it bother you that there's letters and numbers mixed? It's no harder. We just have to think with our full brain. We need to find our LCM. You need to find the LCM no matter what, right? Let's see. It looks like this guy combines everybody. So our LCM can be 3t. That means we're not going to adjust by the missing pieces. That means we can multiply each term. Sometimes I put them in parentheses and sometimes I don't. Sometimes I like to do that so that I can see, oh, I'm going to have to distribute this. This is pretty important, all right, to do it that way. So now I'm going to cancel 3t against the t. That's 3 left. I'm going to write a 3 there, and then later I'll distribute that. 3t over 3t. Oh, this is the happy days. That just cancels completely. We don't have to multiply. There's nothing left over, right, in the denominator. This one, 3t and 3, this cancels and leaves us with a t. So I'm going to write times t. 1 times t is easy, but I'll leave it like that. All right, so now I won't distribute it yet. I'll write it so that you can see this clearly. Right? There's that, 14, and then 1 times t is just t, so I wrote it like that. Okay, now we can distribute. From here on out, it's easy. Okay, so we can do 2 things. Let's see. Let's swim the plain number guy this way. And let's swim the t this way. Cancel, cancel. 4t equals 20. Divide both sides by 4. And I get t equals 5. Yay, that's the right answer. Example 103.3. Okay, now John's going to push us up the learning curve just a little bit higher. Again, he tells us to solve, so that's one hint that we can eliminate our denominators altogether because that tells us it's an equation. We can also see this big bold equal sign. The fact that there's 0 over here, that doesn't change anything. It's still an equation. So we're good. We know that we'll be able to blow these up all together. The tricky part in this one is just figuring out what's our LCM. Can we somehow like add 3 to this one and an n to that one? No. We can't add or subtract to our denominators. All we can do is we can only multiply to adjust the denominators. And that, my friends, is why I prefer to call this the least common multiple, because that m of multiple reminds me I can only multiply. I can't add 3 to this and n to that. It doesn't work like that. So all I can do is multiply things together. So that means our least common multiple is 5 times the quantity n plus 2. Ew, that's ugly, isn't it? But it's still going to work just fine. Now we have to multiply all the terms on both sides. The fact that this is a 0 is not going to hurt us at all. Don't worry about that. So here we go. 5 times the quantity n plus 2. 5 times the quantity n plus 2. And 5 times the quantity n plus 2. I like to write them like that because that's the only thing I ever write up on the diagonal like that, is when I'm multiplying all terms by the least common multiple in an effort to cancel denominators. So that's a special style. John doesn't do that. He can't hit, the printers couldn't really make that happen, but we can. And so this is a very special way that I do that so that I know exactly what I'm doing. All right, now I can cancel. Those cancel, and I'm going to have 5n, right? Here the 5 cancel, and I'm going to be left with the quantity n plus 2. I'm going to carefully leave the parentheses around that and draw these to remind myself I'm going to have to distribute later. And then here, look, this is only 1 on the bottom, but this whole thing times 0 equals 0, so that all just goes away. Which always seemed to me like, this isn't going to work, but it will. All right, so 5n minus 3 times the quantity n plus 2 equals 0. Or as we say in many foreign countries, Z. Okay, I'm ready to distribute. Now this is a minus sign, so I'm going to be careful. 5n minus 3n minus 6 equals 0. Let's add 6 to both sides, and then we'll combine those like terms. 2n equals 6. N equals 3. Oh, so satisfying, right? Crisp and clean. All right. Like most of John's lessons. This is John's genius. Incremental learning, baby steps. We just add baby steps to what we already know. And most of the time the baby step comes at the front end of the problem, right? That's how he sets it up, is he teaches us a basic operation and then he makes it more and more complicated at the beginning. And that's clearly what's happening here. Once we do this thing and cancel, then we're used to what comes after that. All right. That was 103.3. 103.4. Let me just make sure. Yeah, I always knock it out of the camera. I should put little markers on my table, but I've never done that because I work at all different tables. 103.4, ready? Solve, it says. I'm not going to write that down, but I notice it. All right, once again, I cue in on that equal sign. I know I can blow up my denominators and I'm happy. I have to find the LCM. Okay. And again, there's no way we can add. It would be so tempting to say, can't we just add 4 here and then multiply this by 3? No, we can't. All we can do is multiply them together. So that means our least common multiple is going to be 3n times the quantity n plus 4. Oh, it seems needlessly fussy, doesn't it? But it's not. It's what we have to do. So I write that up here on an angle. And again, I see that 0 lurking over there, staring at me like a full moon. It's fine. It's not going to hurt anything. Okay, here's what cancels there. So this will have n plus 4. Oh, I like when the binomial cancels. We'll have to multiply that by 3n. And then this times 0, it just all goes away and we're left with a 0. Okay. I'm going to skip down here. 2 times the quantity n plus 4 minus 6n equals 0. Now it's familiar turf, right? Distribute. Let's swim the 8, and we'll combine these like terms. Minus 8 over here, and 2n minus 6n is minus 4n. There's the n. We want to isolate it. And it's negative 4, so n equals positive 2. I have to say, I like that we start with an ugly problem and then make it even more disgusting, but we get this cute little answer. I find that satisfying. Example 103.5. He tells us to solve. We see the equal sign. Let's blow these guys up. We don't have to put up with them anymore. Again, we can't subtract 2 from this side. All we can do is multiply. It's such a shame, isn't it? It seems like we're making it so hard, but that's just the way the numbers work. X times the quantity x minus 2 for everyone. It's tempting to just not even bother to write it over here, but I want you to show me this every time so that, because we're not always going to have zeros over here, so just get in the habit of going every single term gets a multiplying by the LCM. Don't skip it just because it's 0. Just know it's going to go away fast. X's cancel, and we have 4 times the quantity x minus 2. Oh, I love when that cancels, and it's just 7x, and then that will cancel, and we just have the 0. Okay, 4 times the quantity x minus 2 minus 7x equals 0. Distribute. Do you feel like this is Groundhog's Day? We just keep doing it over and over again. We'll add the 8, and we'll combine the like terms. Minus 3x, that cancels, equals 8. Well, here's one that's not going to come out even, right? Again, I don't like to have my minus sign attached to a number. I like it to float. So I'm going to say x equals minus 8/3. That's correct. Not quite as satisfying as these whole numbers we've been getting, but alas. It's also worth noting that in some of these problems where we have variables in the denominator of the original problem, it's helpful to say in our solution x cannot equal 0, and it can't equal 2 either, can it? Because if this was 2, then 2 minus 2 would be 0. Then we'd be blowing up the kingdom. So it is bonus points to say something like this at the bottom. Anytime you have a letter in your denominator, you have to protect yourself against the catastrophic kingdom implosion. So we'll start doing that in our problems, and I want you to do it in your homework, and I'll show you again an easy way to do that. Example 103.6. Solve equation TNT. That's the way my brain processes that. 4 over P Now, as I'm looking at this and pondering my LCM, that's a 4, by the way. It's not my usual looking for. I right away notice we have letters in the denominator. So I know that P cannot equal 0. And P minus 4 cannot equal 0. Okay? Then I just do a quick little algebra on this. Add 4 to both sides, which tells me that P cannot equal 4. And I can see the logic of that. 4 minus 4 would be 0. But if you're ever kind of having a brain hiccup and you can't figure out what number you can't allow P to be, just set up a little equation, non-equation, right? It's not equal to. But just set that up and solve it, and that will get you to both of these. So this is going to be part of our solution from now on. We want to say, let's not let the kingdom explode. Okay. So we do that as we copy down the problem and notice these letters in the denominators, and we go, oh, dangerous situation, those can never be 0. Now we're ready to proceed with our usual LCM business. And again, that it's the same letter, but alas, that's the best we can do for an LCM. We can only multiply them. We can't subtract 4. Okay, here I go on my diagonal. P times the quantity P minus 4. And again, we have the 0 over here. That's okay. We're just going to play along. Now we cancel. Those cancel. 4 times the quantity P minus 4. It's getting messy. We'll distribute that. I'm going to write that over right away, because that's crazy. The P minus 4's cancel. And it's just going to be 3P, so I'm just going to write minus 3P. There's the minus sign. And then this is all going to cancel when I multiply it against the 0. Hopefully this is starting to feel quick and easy to you. 4P minus 16 minus 3P equals 0. We'll combine the like terms at the same time we add 16 to both sides. 4P minus 3P is 1P, or just plain P, equals 16. Yay! Right answer. Okay. This is a big step, you guys. And I just want to say, this part that we did at the beginning of the lesson, this is huge. Make sure that you understand the difference between expressions and equations, especially when they're in fraction form or rational. Rational just means fractional. We have to be clear on which strategy we can use to deal with the denominators. Expressions, we cannot make them go away. The best we can do is just make the denominators match. When we have an equation, we're in much better shape because we can use the LCM to blow up the denominators and make them go completely away. So when you are dealing with a problem that has fraction, excuse me, I'm just taking a little nap here. You have to know what your goal is. Am I trying to just make them match, or do I have a chance of blowing them up? Okay? Yay. That is the end of lesson 103. I hope you enjoyed it. Next time in lesson 104, we're going to expand on the equations side of it. Okay? I'll see you then. Oh, wait. That was 103. Let's cross it off. Goodbye.